Hi, in this video I'm going to explain the second example of how to apply the concept of conic section to some real-life situations. So let's get to this second case. It says a parabolic dish has 3 meters of width where the receptor device is located. If the receptor corresponds to the foci of the parabola, at what distance from the bottom of the parabolic dish is located the receptor? So I have here sketched how this parabolic dish will look like. So the only information we have is the width of the parabolic dish where the foci is located. Well, the foci will be here, the receptor device. I'm going to do it in here. So this in green, the receptor device. So distance, the width in this case is equal to, I'm going to write here, 3 meters. So we are located to find the distance from the receptor device to the bottom of this parabolic dish. So in other words, we are trying to locate the distance. If this is the foci, we're trying to locate the distance to the vertex of the parabola. Now, here we can make a couple of things. And the origin is not stated, so we can pick it to our convenience, and so we can pick the orientation of the axis. Now, if I would locate the axis, for example, something like this, the horizontal axis, and something like this, the vertical axis, it would be kind of tough to find this the parabolic. We have to rotate the axis of the parabola. So, but we can just do it in a simpler way. Why not we just put the horizontal axis just like this? It will be here our x-axis, and we locate the other one in here. And of course, the simplest way will be just to locate the origin at the bottom of the parabola. That will simplify our work a lot. So let's pick it the simplest case. So I'm just going to write here on the right how this will look like. Here is my axis and my y-axis. Here is my x-axis, x and y. There it is. So our graph will look something like this: a parabolic dish. Watch it completely horizontally, like a plane. Here it is. We know here will be the foci. Here is the foci, and we know that this distance is equal to 3. I'm going to say just 3 without the units. Now, if this is not a perfect drawing, but it will work nicely. The thing is, we are trying to locate the distance from the foci to the vertex, and we know that distance, this distance, is equal to p. Now, another thing we know that's this length from the foci to the borders of this parabola is what we call the latum rectum. This latum rectum, this is would be equal to 3 in this case. Now, we know that 4 times p would be equal to, in this case, 3, which is the length of latum rectum. Now here comes the thing, because we have to, formally write these 2 bars that stands for absolute value. That is to say, if we have a negative value for p, this will turn into a positive value in the result, just for purposes of working with the algebra. But the thing is, as we are setting here these conditions to our convenience, we can clearly see that this parabola is on the right, so it's going to be a positive value for p. So we can just take away these 2 bars, because in any case p is going to be positive for this particular situation we just used. So we can say that p in this case would be equal to 3/4, which is, in other words, p would be equal to 0.75. Now this case would be meters. So basically that would be it, because we have just requested to find the distance from the bottom of the parabolic dish to the located receptor, and that would be pretty much it. As you can see, well, now I just want to say again, if we would have tried to solve this problem without rotating the axis, that is to say, we got here the x-axis and we got here the y-axis, we'll have to face a totally different problem, and will be just we will get to the same result, but in a much more tougher way. So just be sure to pick the simplest case, and we'll get you to the right answer, and that will be it for this case.